Hey viewers, welcome to another episode of my Matlab Programming course. We are at episode 6 here, and today we're going to see our first program using only for and if loops and a little bit of extra stuff that you haven't seen before, but I will explain. It is kind of stuff that has to do with photo editing because that's what we're doing today. So we have to read in an image, we have to open the image, we have to display the image, we have to do all kinds of stuff basically that you will see. But it's all about the for and if loops today and how you can actually use them in a program. So let me first clear this crap because I kind of forgot to do that. Yeah, this is not the first time I started this one. So the problem is my F9 and F10 buttons have been blocked, which is a step and posting things from here to the command window. So I'm going to have to do that manually, which means clicking a lot of buttons. First of all, we're going to start off with CLC clear and close all. If you put a semicolon in between those, you can put them all on one line because the semicolon says this is the end of the command and a new command is starting now. Normally you would start on the next line, but you don't have to do it. So you can actually put them all in one line, and I did that right here. So it's going to clear this, that's the CLC. The clear will clear out the workspace, which is here, there was nothing in that. And close all will close all the figures. There were no figures open for the moment, but we will see that later that it is actually useful. So then we're going to load in our first photo. Our photo is called photo.jpg. So a JPEG. And as you can see, we are using imread for that. And if you want to use imread and you're wondering what does it do, you can type help imread. You can also read this because this is quite a bit of text, by the way. So it might be more useful to use, for example, doc imread. And then you get the whole document, but as a separate file, which is way better to, read. It's just better than having it just as text. And the final one, I already discussed all of this, but is hitting the F1 button. It will pop up imread as kind of a quick help file, I guess. And that is useful as well. So you can see how to do it. For now, I'm just going to tell you this is how you do it, because it doesn't matter yet. So imread photo.jpg, and that is going to be loaded into our variable pixels. And pixels is going to be just loaded now with all of those numbers. So a photo is basically 3 colors, which is the last variable in this thing you see here. You have a length, height, and an amount of colors. So basically you have 3 different colors that are mixed together then in one image. And yeah, so you can see here, the first one is the rows, the first number. The second number is the amount of columns. Yeah, that's true. And the third one is the amount of, layers you have, color layers. In this case, 3. And as you see behind it, it says uint8. Uint8 means that it has a bit depth of 8. Bit depth of 8 means that we have 256 numbers that we can store in it. And since it runs from 0 to 255, that is exactly what we expect. So if I look at this, we can actually look at it here. By double-clicking it, you can see, you can open it. It says it's too big, but you can actually see parts of it if you wanted to. We're going to use this matrix because it's an enormous matrix. It's 3D, and yeah, it has a lot of data in it. So first of all, we're going to get the number of rows in our picture, and those are basically the length of all the rows and the first column. So I'm using the first column and selecting all the rows, that's the column there, and then only using color 1 because otherwise it becomes a 2D array and I don't want that. And basically if I watch this, so if I copy paste this, it is just a whole bunch of numbers. But as you can see, it's a column vector. It's only one column and a lot of rows. And if I want to have the length of that, then it's going to give me one number and one number only, and that is the amount of rows that are available. So for the columns, number of columns, I do exactly the same thing, but I use only row number 1 and then all the columns, and then column number 1. You can also use column number 2 or 3, or I don't care. But yeah, the same thing for both of these variables. So I'm loading them in. It says 532 rows, 800 columns, which is exactly the same as we saw here. Only now I have them as variables. So I have those numbers. They get subtracted from the matrix itself. So if I change the picture, then, or the photo I should say, then it will give me the right number. So if you put in, well, like 800 and 532 there, then if I change the photo, I have to change the numbers. I don't want that. I want this to be flexible because I want to copy paste it for my next example, which is exactly what I did, and you will see that all of the examples start like this. So we are going to continue on, and we're going to step through all of this. Hang on, we're going to do that a little bit differently. There you go. I'll bring it up. There you go. That is our picture. And I will explain to you what it is. First of all, well, figures. So I'm using figure 1, which is what's posted in the top left. This is figure number 1. You can have like 65,000 figures, so you can basically choose whatever number you want. I do recommend that you give it a number. You can also just do figure like this, but I do not recommend that because then you cannot go back to it and, well, get data from it or post new data in it. So if you give it a number, you can address it as figure 1, and you can do that throughout your entire program. So that would actually be very useful. But as I said, you can also just use figure. It will open the next number. So if 1 is already open, it's going to take 2, and if 100 is already open, it's going to take 101. Anyhow, subplot is a way to do this, to get multiple plots in one figure. Normally, one figure is one plot. Subplot works as follows. You have 2 rows, you have 2 columns, and this is position number 1, 2, 3, and 4. So as you can see, 1 is top left, 2 is top right, 3 is bottom left, 4 is bottom right. I have titles on them. Every subplot can have their own title, as you can see, full color, red, green, and blue. So you can see the different color channels of your picture, basically. Then we are going to pick a method here because I actually programmed it, so we have different methods to do our thing. Yeah, we're going to have to restart this, unfortunately. Run through this, and it's going to make my thing once again. No. Bad picture. Yeah, method is 1, which means we're going to go with method is 1. I have an if loop here. I have 3 different methods, method 1, method 2, method 3. And I'm going to use 1 first. So 1, as it says, it is going to use the average value. Here you can see what happens if you just take red, green, and blue. I will show it to you. This is if you just take red and use that as your color spectrum, basically. This is if you use green. This is what you get if you use blue. Yeah, neither of those really stands out, but you can see the difference. There's a lot less red and a lot more blue in the sky, for example. So you may want to choose green, for example, because it's kind of an average. On the other hand, blue gives you more of a sunny day feel, and red gives you more of a, well, we went there at night feel. So we're going to run through this, and we will see that it will pick method number 1. This, by the way, is done to prevent an error, well, not an error, a warning, because we're going to use not the pixels themselves. We're going to make a new matrix and plot our new values in that. Basically, we want to keep our original values intact, and we're going to use a different matrix to put all our new values in and then compare the two in the end. It doesn't really matter for now. You can just forget it. You will get an error if you don't do it, but unless you work with really big photos, it doesn't matter too much. So what we're doing here is we're going to go with method 1, and I shouldn't press that because then the recording stops. So for row number 1 to number of rows, and this is why you need it to extract the number of rows, and from 1 to the number of columns. It's going to run this, and it's going to say the value that I put in my new matrix is the average of the 3 colors. As you can see, it's using row column for each of the 3 statements here, and then 1, 2, and 3 for the 3 colors. So that's red, green, and blue. It's going to take the average of that, mean. You can also just add them and divide them by 3, of course. So do it manually, but mean is one of the functions that you get. And then I'm going to put that into the red channel. In the blue channel, I'm going to put, well, the new value. So this value is going to be put into the green channel and in the blue channel. So all 3 values will be the same, making that you only have gray accents, which means, well, that's what you do if you make black and white. So I hope that's clear what it does. And if I run it, then we're going to skip all the way to here, of course. And it will take a little bit of time. It's taking a lot more time than it normally does. But that's quite all right. It will eventually stop doing something. Yeah, it is done. Normally this takes like half a second. I don't know why it's freaking out. And then we're going to open figure number 2. As you can see, just a different figure. And it says figure number 2. And we're going to say, well, let's see what it actually did. So, oh, did I screw it up here? Yes, because I worked with doubles. I calculated things with it. It's no longer a uint8. It's no longer an integer. So I need to bring it back to an integer. So you have to type uint8 before it, otherwise it doesn't work, and you get a white screen or black screen, both of which can be possible. So anyway, this is what the picture looks like now. Just, yeah, look at it. It is kind of equal to the green one, but it has more clarity and it has a little bit less of those, it still has those black edges in the corners. That's just because they used a crappy photo camera to capture this, because that means that your corners are going to be darker than the rest. So there's not a whole lot I can do about it right now. I can, of course, do everything about that if I wanted to. But you can see it's resulting in a reasonable picture. It's not bad. Anyway, we're going to save this, and we're going to do method is 2 and do exactly the same thing over. So it did clear or close all of the pictures, all of the figures. And now we're going to do method is 2. Method is 2 is the maximum value. So it's going to take the maximum value, as it says here, from the 3 colors and put them in all 3 channels. That's as simple as it is. It's the exact same thing as before. And we're going to have to see what it actually results in, because obviously it's going to be a little bit different from what we had previously. And there you go. As you can see, the air is a little bit brighter here. The faces are a little bit brighter, so there's less contrast. And it's just the colors are now the maximum of each of the colors. Of course, you can do the same thing with minimum values, and that is method number 3. It's kind of lame, but hey, that's what it is. I'm just showing you what it does. I'm not saying that this is the best way to do it. Why did figure 1 bug? I don't know. So we're going to run through all of this. As you can see, minimum value, so now it says min, and it is once again color 1, 2, and 3. And then we're going to see the results in this next figure. Come on. No, you want to. And there you can see, because I picked the minimum value, the air now is very dark. So the air is basically the red air, because the red is way worse than the blue and way worse than the green. Well, the green is pretty bad as well, but it is just a red air basically. But these are now very high detail. There are a lot of contrast in it. You can actually see all of the veins in the stone. And all in all, if you combine the right algorithms, basically, you can make a much better picture from your original picture. And well, in this case, make it black and white. We will see some other things in later stages. But you might have noticed that, well, you cannot really compare the three pictures now. I showed you three methods, 1, 2, and 3, all three of them resulting in a different thing, but you can't really compare them because they're never there at the same time. So we're going to go into example 2 and fix that, because here we're using a for loop for the method. So keep in mind, we now have a for loop. In that there's an if loop, in that there's a for loop, and in that there's another for loop. So we have for loops inside of each other, and that for each of the methods. So in total it becomes kind of big. Also keep in mind that if you select the wrong method, I now have an error message. So if I were to do method is for, if I do method is for and just run this, then it will say error in method selection, because there is no method selected. Well, there is a method selected, but it's not good. It's not a good one. So I put that in there just to give me a warning every time or when something is entered that is not 1, 2, or 3. For this one, it doesn't really matter because I can see that it's 1, 2, 3. But well, in bigger if loops or for loops or if loops, whatever, you may want to include that just to make sure that you're not running into trouble because you entered the wrong value. You want to have full clarity of what's going on. Anyhow, now we have methods 1, 2, and 3. And as I said, they're in a for loop. So what does the for loop do? It runs with the variable method. So method is going to be first 1, then it's going to run this if statement. Then it's going to go to figure, which was on the end of our program before. And it's going to make a figure with the number method plus 100, which means that if method is 1, the figure number is 101. If method is 2, 102, and if method is 3, 103. Keep in mind there's uint 8 here before the picture, before I plot it, because I did know that I should do that. I just didn't do it in example 1 for some reason. Yeah, so it's going to run 3 times, once for method 1, once for method 2, once for method 3. Then it's going to say, well, I'm done here. And we're going to put a stop right in the end there. There you go. So we're going to run through this entire thing and see what happens. It is going to take a moment to process, obviously. This shouldn't, if you're not recording, this shouldn't take more than like a second. But since I'm recording now and I have a lot of crap in the memory, this might actually take a while. So figure 1 is going to stay the same, because figure 1, I only plot that outside of the for loop. So it's plotted over here in the top. And I'm never touching it again. So yeah, it's kind of easy to see. So I do have all of the figures now. This is number 2 and then number 1. So we have 1, 2, 3. And you can see the differences in the sky, for example. Very bright sky, very, well, average sky, and very dark sky. But you can also see the differences in the details. So if we look at the shadows are much deeper in the minimum value than they are in the maximum value, which is this one. All in all, you can pick different algorithms and say, for example, if blue is the main color, because most of it is gray, so it doesn't really matter. I mean, most of it is almost gray. So if the main color is blue and it's well above everything else, I want to have, well, for example, this one or this one, whatever you want. You can just make it up. You can select different regions of the photo with that, or different colors should be amplified in different ways. All in all, you can do whatever you want with it. It is just a method to show you how foreign if loops work. And this is not to tell you how you should be doing photo editing, because, well, this is not the way. Obviously, you want to pick the whole photo and just edit it in one go normally. But really not the problem here. Then we're going to example number 3, and I kept all of the figures open just to show you what this close all crap does. Yeah, run through that, and then we're going to run this. And as you will see, it will close all of the figures. There they go. So CLC, we already saw that. Clear, we already saw that. But close all, I hadn't demonstrated that yet. It just closes all the figures. It's easy enough. So we're going to start at number 1. I obviously had to try them out, and that is why there's something there. So yeah, once again, we're reading in a picture. This time it's called underwater.jpg, and it has a number of rows, number of columns, and we will show the photo in figure number 1. There it is. So as you can see, yeah, I'll run this one. That's a clearer vision of what it actually is. It is an underwater photo, so it's completely blue. And as you might notice, there is a little bit of plant life over here. I didn't really select this photo, but yeah, it's just a photo. Normally plant life, as you can see, becomes way too blue on these pictures. So what we want is we want to have that that plant life to be green and the skin tone to be back a little bit. This is, by the way, a very bad picture. This is a terrible camera which these guys have, but well, for the demonstration here, it should be good. So we split it into red, green, and blue once again. So here you can see full color, red, green, and blue. I'll enlarge it a little bit. And as you can see, blue is way too bright. Red is yeah, underlit. And yeah, the green is the only one that's kind of average. So we're going to make use of those facts and edit the photo based on that. So basically we need more red, we need less blue, and the green is okay. What we're going to do is we're going to set up a new matrix, that's what. And we're going to turn pixels into a double. So pixels is our photo, and we're going to turn that into a double, because if you multiply or add based on this, and especially subtract, then you're going to run into errors if you keep it as a uint8, because uint8 cannot go below 0. It also cannot go above 255. So that is a problem, of course, because we want to, and they're all integers. We want to multiply here by 0.8 in this case. And yeah, it's going to run into trouble, so don't do that. Keep in mind you do have to switch back to uint8 later on to make sure that you can actually plot it. But those things, so making it a double or uint8, is really something that doesn't happen a lot unless you want to work with pictures, because normally you don't work with unsigned integers or something like that. You virtually always work with doubles. So we ran the calculation here. What the calculation does is, for the red channel, which is this one, so the new red channel is going to be 0.8 times the old red channel plus the green channel. So we have this is the first thing that's done. It adds the red channel and the green channel. And because the red channel is, well, there's only slight data in that. It's going to do that times 0.8 to make sure that it doesn't get too bright. And then basically it keeps the other two things. The green will still be the green, and the blue will still be the blue. So just showing you what this results in. Yeah, let's run it. There you go. So as you can see, if I put them under each other, the red channel is now much, much better than the old red channel. It still may not be perfect, but you can also see that the photo itself just looks way more natural. It's not that super bright underwater color that you get from crappy cameras, because there's not enough red light in this, which we could see from the red channel. There's not enough red light penetrating the water, and that is why it becomes so blue. In reality, our eyes do not see that as blue. Our eyes see water as almost just transparent, completely colorless. And so this one is much better. You can also see that the orange in the bathing suit has returned, and apparently she has red hair. And you can see the orange here has returned. Also, the green here is now actually green, whereas the rocks are just gray. So it becomes a lot better colored. Now, well, as I said before, this is a very crappy picture. But we do have better pictures, so we're not going to change anything. Oh, I will show you the final picture. There it is. So you can see it full screen. So as you can see, the colors in the bathing suit have completely returned. The green has returned, and yeah, for the rest it's just all gray rock. So there's not a lot of color to return. So how do I know this is the right one? So if we do another picture, we're going to underwater 2, and I will just get all of the breakpoints out because, well, we've seen pretty much what it does. We're going to run this, and as you can see, we have a new picture here. I'm going to put them in the same order that we had. Nope, don't make it screen sized. So this is the original picture. Well, this is the original picture. As you can see, it is a fake picture, by the way. You can see that in a moment. But as you can see, the blue channel becomes very blue. The rocks, yeah, the rocks are here, it's green, which we saw in a real picture is not the case. So this is an edited picture, but we will see that here, because as you can see, the red channel, although it's less bright, it is only less bright where it's blue. So everywhere where it's blue, so that's the background basically, there you can see that the blue channel actually, well, is too bright. The green channel is okay, and the red channel is, well, too dark. But all of the fishes are fine, which means it's a fake, because these fishes in the background can normally not even be seen without editing. So if we edit it with the same thing, you can see that I made the red channel a lot better. It's almost equal to the green channel now. And yeah, the overall picture just becomes a little bit less of that, yeah, annoying, very, very blue. The rocks also become a little more rock colored, so a little less green. But as I said, this is a fake picture, so I can't really make it better, because there is no better, because it's a fake picture. Someone already did this. So someone took the background, which is probably a real photo, and then put all these fishes in it. And the fishes, yeah, they didn't do anything to it. So basically, there's not a lot I can make better. Then 3 is, I think, the best one to demonstrate. Yeah, this is the best one to demonstrate the effect. As you can see, it's someone sitting in the water. Yeah, let me just arrange these pictures a little bit. So we are going from a real picture this time. So this one is an actual picture. You can see it here in well, full size. You can see that the blue is kind of tinting the body, so the body is not actually body colored. The water is completely blue-greenish, and the sand, even though it's sand color here, does not stay sand colored. You can see the beach for, well, all the way up to here or something. But especially the colors that, well, the skin color, for example, we want to fix that. So if we run the algorithm, we get to this. Oh, first of all, let's show this, and you can see that yeah, the sand color stops here. So the sand color itself stops here, but then the sand stops somewhere here, and the rest of the water just becomes, well, bluish. And then we have a green, which is completely saturated, and blue, which is actually not too saturated. So we might want to switch it up a little bit. But if we apply the same algorithm and we make the red a little brighter than it was, then we get a much better skin tone. As you can see, this is actual skin tone. You can still see it's underwater. You can see the sand color up to here, where it mixes with the watercolor, which is this color for our eyes. So if you were to be in this water, and you would sit where the photo camera is actually sitting, this is what you would see, because our eyes are way better than this crappy camera is. So the purple, of course, becomes purple, the white becomes white, yeah, and the skin color, as I said, becomes skin color. So it is just a big result going from this to this, or, well, this. And, well, that's all because you just separate the three channels and then just learn that, well, the red is completely underlit, so we need to brighten up the red, add more red in there, and then it becomes, well, real again. But as you might have noticed, not every photo is exactly the same, so there's that. So the last one then, just as a demo, this is from some Russian site. It's apparently an underwater cave that we will see. And, well, obviously this is the picture that, this one is the picture that they posted online. It is completely blue. There is no way this is what it looks like. I mean, in reality, this does not look blue. Otherwise, you would bring a different color light, because, well, there's no way you want to go into a blue environment like that. If we look at the split, you can see the red is almost just black. The red channel is almost non-available. It's only available where he actually shines with his lamp, and only then it is, because the light spot is actually all the way here. But only where it's super bright light, that is where there's red light. The rest is just dark, completely dark. So if we edit that and we get it to be this, which is way better, of course, then we get this as a final picture. And I will show that to you on full screen. And it becomes much more of a, well, a real color. I mean, obviously it's not purple there either. You can actually make it gray very easily, but we don't want it gray. We want it to have some kind of color. And this is apparently, well, seeing from the other pictures, especially picture number 3, this is much closer to what the picture should look like if you were really swimming there. So anyway, just a demonstration of what you can do with photo editing with for and if loops, because that's all I'm using here. In this case, even only a for loop. But in the previous examples, also if loops. And you can do quite a lot with them. And, well, this is something you could try out at home. As I said, imread, important. uint8 transformation back and forth. So if you want to calculate with values, they need to be doubles. If you want to use imshow, they need to be uint8. So you can just do, yeah, to make it easier on yourself, you can make a pixel starts off as a uint8, but you can make, after your calculation, the statement pixels new, which is so far a double, is uint8 pixels new. And that will transfer everything to uint8, and then you don't have to do this anymore. I'm going to keep it there just because, well, I like it like that. Because this actually would transform the variable, this only changes the variable inside of this statement. So even though if I don't have this, then after this entire thing, it will still be a double. And I personally like that. I like to do my calculations with a double and keep them as a double. And then every time I have to plot them, I just add uint8. So yeah, as I said, the only thing you need to learn here is imread to do photo editing. And well, this length statement is pretty useful. Also size, we use that here. It's kind of useful. Size will give you all, well, all of the things that you can get out of this matrix. So length, width, and or length, height, and amount of colors. So it will give you three values basically. And if you use zeros like this, so zeros or ones makes a matrix of zeros or ones with the size that you say. So in this case, the size is the same size as pixels was, and that's why I use it like that. So anyway, hope you learned something today, and I will see you next time.